Welcome to this XDK2MAM video tutorial for the IOTA Data Marketplace package. Today, I'll be guiding you step by step through the process of connecting Bosch's XDK110 device to IOTA's Data Marketplace, or DMP. This is a proof of concept launched by the IOTA Foundation to connect people willing to offer their device's data with others that might have an interest on buying it. We will set up the XDK110 and a Node.js server that will retrieve the data and publish it to the DMP using Masked Authenticated Messaging, or MAM. But before we start, let's talk briefly about what the IOTA Data Marketplace proof of concept is. If we enter data.iota.org, we can see this site, which displays a map of the sensors all over the world. The idea is to allow producers to sell their sensors stream to others that might need that kind of information and who would pay with IOTA. XDK2MAM has been a participant of the DMP for some time, and we've created a solution to easily connect the XDK110 to the DMP. The IOTA Foundation has open-sourced the code for the DMP. If we head to the IOTA GitHub, you will find the code and instructions to run your own instance of the DMP. Now, let's see what software we'll be using today. XDK Workbench is an Eclipse-based IDE. If you don't have it installed, you can go to xdk.io. In the Downloads section, find the version that suits your OS. This software is essential to import the code and flash it to the XDK110. You will also need to have Node.js installed. You can get it by entering nodejs.org and downloading the version that suits your system. If you want to know whether you have Node.js installed, you can type the command line node -v. If it returns a version number, then it is already installed. The git command line is going to be very handy for this method because it will help us install the XDK2MAM repository. So, to begin, I'll go to the XDK2MAM website and into the section The Code. Here you'll find different solutions to send the census data to be published in the Tangle. Today, we'll be using the DMP package. This method uses a microSD card to store the config file, allowing more portability, as all settings will be saved onto the microSD that goes into the XDK110, and you can easily modify the config file should you need to. Otherwise, every time you want to change the settings, you would have to recompile the code and flash it to the XDK110, which is far more cumbersome. So now we have to go here. In GitHub, I will copy the repository and go to the command line to do a git clone that will copy everything we'll need to the C drive. Now let's create a folder at C called tutorial-dmp and enter it to clone the XDK2MAM repository contents with Git. When we go to the folder that was just copied to our drive, we can see a folder called XDK2MAM that contains the different methods to connect our XDK110, including DMP. In order to avoid confusions, I'll delete all the other folders. And inside the DMP folder, there's a config file. So, first of all, we have to copy that config file onto the microSD card and then open it. Here you can change the device name, which is very useful if you want to easily tell apart your devices when you have several of them working. Then you must enter your Wi-Fi SSDI, your password. You can also easily modify the request interval in which the XDK110 sends data. It's expressed in milliseconds here, so the data will be sent every 30 seconds. And here you can choose which of the sensors will be included in that dataset. Now we save these changes and eject the microSD card. Then we plug it context up into the XDK110's microSD slot. So the next step is to open XDK Workbench and go to File, Import, Projects from Folder or Archive, next Directory, and browse to the folder we just downloaded, Tutorial DMP, then DMP, XDK2MAM-C. This is the folder we were looking for, so now click OK and then Finish. Now right-click on XDK2MAM in the Project Explorer panel and select Clean Project. Once the cleaning is complete, right-click once again and choose Build Project. This is going to compile the project, and depending on your CPU, this might take several minutes. The compilation process ended correctly. Don't worry if you get some warnings, that's normal, as long as it states that the compilation was correct. Now connect the XDK110 to the computer USB port and then turn the switch to on. Next, we'll be flashing the code by clicking this button. We have to give it some time, and as soon as it finishes flashing, the XDK110 is going to start sending the data. And this is it, the first dataset. Since we haven't yet set up the Node.js server that will be listening for that information on the IP provided at the config file, we will get some errors at the Workbench console after every dataset. Now let's take a look into the Node.js folder. We have our dmp.js, which will be in charge of getting the XDK110 and sending it to the DMP. As you can see, we also have a config.json file. There are values on this file that will need to be edited to include information we will get from the DMP once we create a device. So let's run the command npm-i to install all the needed modules. Now it's done, we need to head to the Data Marketplace. Keep in mind that the IOTA Foundation has open-sourced the code of the DMP. So for this tutorial, we will be using an implementation by Dave DeFichte, located at the-real-dm.firebaseapp.com. Once we open the website, we need to click the dashboard link and we will be automatically logged in with our Google account. As you can see, we can start creating devices, so let's add one by clicking on Add Device. We will create an example weather station offering temperature, humidity, and pressure. For the sake of this tutorial, we will use the default values for Berlin, Germany, in latitude and longitude. So let's add 2 extra fields to have 3 devices and complete the fields for our values. Field ID needs to be filled with temp, press, and hum, while you can enter whatever you want at field name. Finally, let's assign a price of 1 IOTA per data stream. This is how much every single data stream will cost to a buyer. Once we've completed all the fields, let's submit the form. Now let's get back to our Node.js folder and open the dmp.js file. If you want to know why we had to use temp, press, and hum on field ID, check the code lines 73 to 84. You will see here that these are the names we defined for the data coming from the XDK110. To go on, we will need to edit the config.json file, which is located at our XDK2MAM-Node.js folder to reflect the device ID, private key, and the endpoint being used by the DMP website. Now head to the DMP dashboard and click the Download Published Script link on the device we created. This will download a zip file containing the template provided by the IOTA Foundation, including a config.json file with the values we will need to replace in ours. So copy the content of the config.json file located within the zip file and paste it in our config.json. All the needed values are now ready, but we need to change debug from true to false in order to allow data publishing. Once that is changed, save the file. Now let's get back to the console and run node -dmp.js to start the server. As we can see, the Node.js server has started at port 8080 and it's now waiting to get some data from the XDK110. The data finally arrives and we can now head back to the DMP dashboard to open the device on a new tab and see the data streams being published. So we just went through the process of connecting Bosch's XDK110 device to IOTA's Data Marketplace. And this is it for today. Thank you for viewing this XDK2MAM video tutorial. For more information and resources, go to xdk2mam.io.